Did you hear the question clearly?
Yes, sir.
So question was?
More number of ions,
Per?
1 molar solution.
What was the question?
Um, सर कितने ज़्यादा आयंस प्रोड्यूस होते हैं इन 1 मोलर सॉल्यूशन?
And then I did not ask that. I asked you, which of these two solutions has more number of ions per unit volume?
Per unit volume.
Yes, I asked you per unit volume. So what is the answer? A or B?
सर A.
Again, good. So the answer is B. Again, tell me, what was the question?
सर मतलब पर यूनिट वॉल्यूम बताना था,
हाँ जी.
बट B is not 100% dissociated.
Okay, and then I ask you a question, another question. You have won two lotteries, but you can encash only one of them. Okay. In one lottery, you get 5 lakh rupees and you get 100% of it. In another lottery, you get 50 lakh rupees, but you get only 50% of it. Which is the one you are going to choose?
The second one.
Why? It is 50%.
पर ज़्यादा है, हाँ.
Now think again. It was 1 molar 100% dissociated, which gives us 2 mole of ions, and it's written there. The second one is 10 moles, 90% dissociated. The 90% of 10 is more than 100% of 1.
Yes, sir.
And what does molar mean? I haven't given you a question, I have given you the answer. What does molar mean? Molar means the number of ions per unit volume. Here it is 2, here it is 18. The question was just which one is greater. Clear?
Yes, sir.
So then be very careful. You have to listen the question very carefully. Do you know what you were listening to? You were not answering me how many ions are present per unit volume. You are actually answering me how many ions are present per unit mole. This one has 2 mole of ions per mole. This one has 1.8 moles of ions per mole. So if I talk about per mole, then the answer is A. If I say per unit volume, the answer is B. And here comes out to be the difference. If I talk about the kappa, then kappa would be higher for the second one. And if I talk about the lambda would be higher for the first one. Is it clear? So the question is
Yes,
very
sir.
simple. Which is going to have a higher molar conductance and which is going to have a higher conductivity? So molar conductance would be for the first, conductivity would be for the second. Clear?
Yes, sir.
Okay. Now, the next thing. Let's say we have two more solutions. There is a solution C, and that solution C is 0.1 molar NaCl. Okay. There is a solution D, which is 0.1 molar Na2SO4. Now both are 100% dissociated. Now could you please tell me which of these two solutions has a higher kappa and which of these two solutions would be having a higher lambda?
So both will be the same.
Ananya, think again. Could you just write the equation for the dissociation of both of these? See what is going to be formed. Count the number of ions being produced.
So second,
Yes. Which second has what higher? Lambda or kappa?
uh, so lambda.
And which of these two would have a higher kappa?
Mm, the conductivity different होगी.
किसकी कंडक्टिविटी डिफरेंट? दोनों की? हाँ, अलग होगी.
तो सेकंड वाले का ही होगा.
कापा भी ज्यादा सेकंड वाले का होगा और लैम्डा भी ज्यादा सेकंड वाले का होगा. यही कह रहे हो आप?
यस सर.
सही कह रहे हो. क्योंकि सेकंड वाले के अंदर 0.1 मोलर कंडक्टिव 0.1 मोलर अगर हम लेते हैं तो Na2SO4 डिसोशिएट करके 3 आयंस बना रहा है. तो इसकी कंसंट्रेशन आयंस की 0.3 मोलर हो जाएगी. और पर मोल की भी बात करेंगे तो यहाँ पे 3 आयंस हैं, इसमें 2 हैं. तो यहां पर डी का कापा और लैम्डा दोनों ज्यादा हो जाता है. नाउ दीज क्वेश्चंस जस्ट टेल यू कि कापा और लैम्डा ऑल्दो रिलेटेड हैं, पर फिर भी हमें दोनों को अलग अलग ही निकालना पड़ेगा. ऐसा कोई रूल नहीं है कि अगर इसका कापा ज्यादा तो इसका लैम्डा ज्यादा होगा. तो इट कुड बी एनीथिंग. किसी का लैम्डा, किसी का कापा, और दोनों भी किसी एक का भी हो सकते हैं. इज दिस क्लियर? दिस इज व्हाट वी हैव एज कापा एंड दिस इज व्हाट वी हैव एज लैम्डा.
यस सर.
ओके. नाउ ये हमें समझ में आ गया कि किस तरीके से कापा और लैम्डा वेरी करते हैं और किस तरीके से हम डिग्री ऑफ डिसोसिएशन और किस तरह से हम बात कर सकते हैं. नाउ हमें इतना पता है कि जैसे जैसे कंसंट्रेशन बढ़ता चला जाता है डिग्री ऑफ डिसोसिएशन कम होता चला जाता है. तो अगर हम लैम्डा की बात करें तो लैम्डा इज गोइंग टू चेंज इन अ डिफरेंट मैनर. ओके. हमारे पास एक इक्वेशन है. नाउ दैट इक्वेशन इज नोन एज द Debye Huckle on Sagar equation. So we have the Debye Huckle on Sagar equation. Now this equation is more appropriately termed as ABC. Here we have lambda is equal to lambda naught minus B under root C. This is A, this is B, this is C. This lambda is the molar conductance at a given concentration. This is the molar conductance at infinite dilution. This is a constant and this is concentration. Here if we talk about, we find that the molar conductance of a strong electrolyte would go as a straight line having a slightly negative slope. So the slope would be like it goes like this. This would be the molar conductance of a strong electrolyte, something like potassium chloride. Now, we can even talk about the molar conductance of some weak electrolyte like CH3COH. CH3COH is undergoing the dissociation and here it forms H plus CH3COO minus. Are you able to see entirely of it?
नो सर.
Which part?
तो CS3 तक दिख रहा है बस.
So we have CH3COOH in equilibrium with H plus plus CH3COO minus. Now is it visible?
Yes, sir.
Here we have 1 minus alpha, here it goes alpha, here it goes alpha. If we multiply it by C, we get it C into 1 minus alpha, C alpha, C alpha. This is what we get. Clear? Now we have something called Ka. Ka would be equal to concentration of H plus into concentration of CH3COO minus upon CH3COOH. Now this comes out to be C alpha square. Remember it? That's what you did in the chapter equilibrium in the 11th class.
Yes,
Now,
sir.
this alpha would be equal to under root Ka by C, while the concentration of H plus, which is equal to the concentration of CH3COO minus, is equal to C alpha, which is equal to under root KAC. Any confusions here?
No, sir.
Okay. Now, what you can see is that alpha is inversely proportional to under root of C. Alpha is inversely proportional to under root of C.
Yes, sir.
Okay? And molar conductance depends on alpha, because alpha is the number of ions per unit mole. So if molar conductance depends on alpha, that means molar conductance would be proportional to 1 by under root of concentration. Clear?
Yes, sir.
Now, lambda would be equal to a constant multiplied by 1 by under root concentration. Anya, could you make me the graph of 1 by x, graph of 1 by x versus x? Could you make the graph of it? What would it would be like?
सर x मतलब किसी भी टर्म्स में
किसी भी टर्म्स में x एक वेरिएबल ले लो.
और
1
वो
by x.
इनवर्सली प्रोपोर्शनल है.
हाँ. What kind of a graph will it be?
सर कैसे दिखाऊं?
नहीं दिखा सकते हो आप.
सर ये
हाँ, बिल्कुल सही. Right you are. So, here also we are making the graph of constant 1 by concentration. So, graph goes like this. Now, these are the two graphs. These are the graphs of the strong electrolyte and the graph of the weak electrolyte. So, these two graphs you have to make on the same scale, and that would be it. Clear? Now, having talked about these, let's get along with one very important concept, and that's called the Rash Law. Have you all copied it down?
सर वो साइड वाला है, इस साइड वाला.
Just do it quick.
सर आगे
ठीक है. Write the Rash Law of independent migration of ions. Rash Law of independent migration of ions. Write the statement. At infinite dilution, each ion at infinite dilution, each ion moves independent at infinite dilution, each ion moves independent of any other ion present in the solution. At infinite dilution, each ion moves independent of any other ion present in the solution. Full stop. The molar conductance, नहीं एक मिनट molar नहीं, the total conductance of the electrolyte solution, the total conductance of the electrolyte solution is the sum of conductance of all the ions, sum of conductance of all the ions in the solution. Full stop. The molar conductance of the electrolyte, is the sum of molar conductance of the individual ions, is the sum of molar conductance of the individual ions at infinite dilution, multiplied by their respective stoichiometric coefficients. Okay. So that's what we have as the Rash law of independent migration of ions. And here we have another definition of infinite dilution. We had written the definition of infinite dilution. We are going to write it once again. Write it. Infinite dilution. The concentration beyond which the concentration beyond which any further dilution, the concentration beyond which any further dilution does not change the molar conductance or does not increase the molar conductance, does not increase the molar conductance of the electrolyte. Okay. So getting with the Rash law, we can simply say that let us say we have potassium chloride. Potassium chloride dissociates to give K plus plus Cl minus. So lambda naught of KCl would be equal to lambda naught of K plus plus lambda naught of Cl minus. In the same manner, if we are having K2SO4, which gives us 2K plus SO4 2 minus, then here lambda naught of K2SO4 will be equal to twice the lambda naught of K plus lambda naught of SO4 2 minus. If we have something like Al2SO4 thrice, it gives twice of Al3 plus thrice of SO4 2 minus. So here it would be something like lambda naught of Al2SO4 thrice is equal to twice the lambda naught of Al3 plus and thrice the lambda naught of SO4 2 minus. So if we have an electrolyte written as AXBY, which gives us x of A y plus y of B x minus, then here the lambda naught of AXBY would be equal to x of lambda naught of AY plus y of lambda naught of BX minus. Is it clear?
Yes, sir.
Now, when we talk about this Rash law, this law is valid for strong electrolyte as well as weak electrolyte. But it can be experimentally verified only for the strong electrolyte. Reason is very simple. Strong electrolytes are only one which are completely dissociated. ठीक है ना? तो यहाँ पे हमें completely dissociation की बात करनी होती है, तो इस वजह से हम strong electrolytes की बात कर रहे हैं.
Yes, sir.
Clear? तो अब अगर हम एक वीक इलेक्ट्रोलाइट की बात करें So talking about a weak electrolyte like CH3COH, तो CH3COOH कि अगर हम डिसोसिएशन की बात करें तो इट गिव्स अस CH3COO minus plus H plus. So if I need to talk about the lambda at infinite dilution of CH3COOH, so it should be equal to lambda naught of H plus plus lambda naught of CH3COO minus. Now I cannot find the lambda infinity of CH3COH directly because it's a weak electrolyte, but I can get along with a round off way. Now how do I get along with the round off way? What I do is I take the lambda naught of HCl. Now this would be equal to lambda naught of H plus plus lambda naught of Cl minus.
Yes, sir.
Then I can get along with something like lambda naught of CH3COONA. This is a salt, it's a strong electrolyte, so I get it as lambda naught of Na plus plus lambda naught of CH3COO minus.
Yes.
If I add these two, I get the lambda naught of H plus, lambda naught of Cl minus, lambda naught of Na plus, and lambda naught of CH3CO minus. I get Na plus and Cl minus extra. So what I do is, I take lambda naught of NaCl, which is lambda naught of Na plus plus lambda naught of Cl minus. I add these two and subtract this. If I do it, I get lambda naught HCl plus lambda naught CH3COONA minus lambda naught of NaCl, which is equal to lambda naught H plus plus lambda naught of CH3COO minus, which is equal to lambda naught of CH3COOH. Is this clear?
Yes, sir.
Okay, so that's what we can do. So we can use Rash Law to determine the molar conductance, theoretical molar conductance of a weak electrolyte at infinite dilution. Clear?
Yes, sir.
The only condition is that the electrolyte that we are talking about, they must be strong electrolytes. The electrolytes which we are using them to calculate, they must be strong electrolytes. We can't use water. Water is a weak electrolyte. But we can find the molar conductance of water at infinite dilution using these combinations. I have given you the combination for acetic acid. Could you give me the combination for ammonium hydroxide?
Ammonium hydroxide.
NH4OH.
NH3 plus H2.
NH3 plus H2O is the combination. These are not ions. If I talk about NH4OH, NH4OH, it is supposed to get dissociated to form NH4 plus plus OH minus. So here, lambda naught of NH4OH will be equal to lambda naught of NH4 plus plus lambda naught of OH minus. Now give me the combination of the three strong electrolytes which are going to give me this answer.
NH4OH.
I need to get of NH4OH, but NH4OH is a weak electrolyte.
Yes, sir. तो NH4 plus और OH minus.
अलग अलग नहीं मिलेगा ना बेटा,
अच्छा,
इंडिविजुअल
तो
आयंस नहीं मिलते ना हमें, जैसे कि मैंने एसिटिक एसिड का निकाला था, एसिटिक एसिड के अंदर हमने एसिटेट आयन को किसी कंपाउंड से लिया, H प्लस को किसी और कंपाउंड से लिया.
सर H2 सर H2 और डिसोसिएट होके क्या बनाएगा
H प्लस और OH माइनस, लेकिन H2 एक वीक इलेक्ट्रोलाइट है, तो H2 हम यूज नहीं कर सकते ना यहाँ पर.
सर पता नहीं अभी. हम वाटर यूज कर सकते हैं.
वाटर नहीं यूज कर सकते ना. आपको 3 स्ट्रॉन्ग इलेक्ट्रोलाइट लेने हैं जिनसे आपको ये आयन मिले, NH4 प्लस मिल जाए, OH माइनस मिल जाए, और फिर जो एक्स्ट्रा इलेक्ट्रोलाइट, एक्स्ट्रा आयन हमारे पास आएंगे वो हम सब्ट्रैक्ट कर देंगे, वो तीसरा इलेक्ट्रोलाइट होगा.
NH4Cl.
Cl, yes you can. NH4Cl से आपको NH4 प्लस मिल जाएगा.
यस सर.
और
सर उससे हमें NH4 मिल जाएगा, बट OH तो तब भी नहीं
तो किसी
होगा.
और से लो ना उसे.
नहीं मतलब सर किसी और का ही सोच रही हूँ, किसी और से.
कोई भी स्ट्रॉन्ग इलेक्ट्रोलाइट ले लो जिससे OH माइनस मिलता है.
OH माइनस से मिलता है.
कोई भी स्ट्रॉन्ग बेस ले लो ना.
सर NaOH.
परफेक्ट, नो प्रॉब्लम्स.
और फिर सर NaCl माइनस कर देंगे.
कंफर्म, कोई दिक्कत ही नहीं है. ठीक है ना.
यस सर.
तो NH4OH की जो मोलर कंडक्टेंस है, दैट विल बी मोलर कंडक्टेंस ऑफ NH4Cl प्लस मोलर कंडक्टेंस ऑफ NaOH माइनस मोलर कंडक्टेंस ऑफ NaCl.
यस सर.
Okay.
Yes sir.
Now, I am giving you a peculiar combination. Let's say lambda naught of BaOH twice is X. Lambda naught of NH4Cl is Y. And lambda naught of BaCl2 is Z. Could you give me the molar conductance of NH4OH in terms of XYZ?
NH4OH.
Yes, again the same thing. In terms of XYZ.
X plus Y minus Z.
No, it is not. Think again. Had it been this, I would have not given you the question.
Molar conductance of NH4OH, right?
Yes, it
तो
is. अब चेक करो, एक बार ध्यान से देखो.
OH whole twice है.
Yes, बेरियम हाइड्रोक्साइड में OH दो है, मुझे एक चाहिए.
सर डिवाइड बाय 2.
Yes. किसको डिवाइड बाय 2 करोगे?
सर X को.
हाँ, x डिवाइडेड बाय 2. और
X डिवाइड बाय 2 प्लस Y
yes,
माइनस Z डिवाइड बाय 2.
yes, now it is the answer. Clear?
यस सर.
ठीक है. So Rash Law can be used to determine the molar conductance of weak electrolytes at infinite dilution. ठीक है, अब एक और बात, बस एक छोटी सी बात, and we are going to finish the class, and that is lambda molar is proportional to alpha. Okay, while lambda not molar is proportional to 1. So if I get lambda molar upon lambda not molar, it would be equal to alpha.
Yes, sir.
तो सीधी सी बात यह है कि लैम्डा मोलर हम मेजर कर लेंगे बाय मेजरिंग द कापा, लैम्डा नॉट एम हम कैलकुलेट कर लेंगे और इससे हमें डिग्री ऑफ डिसोसिएशन मिल जाएगा. ठीक है, सो
Yes, sir.
दिस Rash law is used to determine the degree of dissociation of weak electrolytes. Is it clear?
Yes, sir.